All right, guys, welcome to our absolute value class. Of course, Jim from the office, he likes to say absolutely I do. So I titled this class Absolutely Value I Do. If you don't watch The Office, you have no idea what this means. All right, guys, shall we get into it? Am I recording? Okay, yes, we are. Anyone have any plans this weekend? It's Friday. You guys got anything going on? Drinking, studying, sad life in Italy, quarantine, movies, friendly golf round, trying to write with my left hand, that's weird, enjoying guava, playing tennis with my wife, cricket, hey Greg, Champions League, GRE, watching Dark, and then watching Dark again, and then again, because you didn't understand what the hell was going on. The gym. I don't know what the gym is. All right, guys, let's get into it. So absolute value has a very simple rule. And if you're aware of what this rule is, absolute value questions are really not that hard, to be honest. You just have to know what the rule is. So let's actually talk about what the rule is. So if you have an equation like this, here's the rule. This is actually two different equations. So what you do is you kind of cross out the bars, cross out the jail, and you just write it as x equals 5. So in this case, you change nothing. You just change nothing at all. And then the second equation is x equals negative 5. That's it. That's the rule. Pretty straightforward, right? Now keep in mind, the negative sign, does it go on the x? Yes or no? No, don't put it on the x, right? Don't put it on the x. Put it on what is on the after the equal sign. Okay, so let's do it again. So here's the first equation. You just change nothing at all. You just cross out the bars. X equals 5. And then the second equation is x equals negative 5. That's it. That's the rule. All right. Let's look at another example. So this one is a little bit more complicated, but the rule stays. So the first one, you change nothing. X minus 3 equals 4. And then in the next one, you do x minus 3 equals negative 4. That's it. And so what is this going to be? X is going to equal to 7, or x is going to equal to negative 1. Now, can I test this out? Can I plug in these values? Yeah, I can plug them in. Let's see if it works. So 7 minus 3, absolute value of 4. Yep, that indeed equals 4. Negative 1 minus 3 would be negative 4. Absolute value, indeed, that equals 4. See, pretty simple rule, everybody. Any questions so far about this rule? Hey, Jenna.
Hello, Greg. So it's been a while since I've done absolute value, but for the second one, could you have done like negative x plus 3, or is that wrong?
That's usually the mistake that people make, is they put the negative side over what's on the absolute value. Whenever I do these problems, I always remind myself, I say, don't put the negative value there. Don't put the negative value there. Put it over here on the 4. Put it here over on the 4. So just kind of make sure you're focusing on what comes after the equal sign.
Okay, thank you.
Okay, any more questions about this? All right, here's another example. Let me kind of clean this up. All right, how about you guys try this one? Now, keep in mind, before you apply the rule, do you want the absolute value chilling by itself? Yes or no? Yeah, you do. No, you do. You want the absolute value chilling by itself, right? Right now, the absolute value is not chilling by itself. So what should I do first? You guys can tell me in the chat box. Yeah, you should plus 7 to both sides. And then what you get is absolute value of x equals 19. And of course, we have our two equations, x equals 19, x equals negative 19. Okay, pretty easy. Pretty easy. Let's look at another one. Now, here's kind of the funny thing with inequalities. So everyone, this is an inequality. And the funny thing about inequalities is they sometimes can flip. So keep that in mind. So equation number 1 is x is greater than or equal to 6. So this is basically when you change nothing. We also have x is negative 6. Now, can I keep the inequality this way, or do I have to flip it? Yeah, you have to flip it. So whenever you guys are doing an inequality, don't forget to flip. All right, now let's test this value. Give me a number that is bigger than 6. Anybody? 7. Okay. If I put 7 in here, does it work? Yes or no? Yeah, it works. Okay. Give me a number that's less than negative 6. Yeah, negative 8. If I put in negative 8 here, does it work? It sure does. What if I didn't flip it? Like, what if I left it like this and I say, okay, greater than or equal to negative 6, and I try negative 3. Does it work? No, it doesn't. So this is why some absolute value equations look kind of funky. Because if you actually kind of, graph this, so we have two equations, right? X is greater than or equal to 6. X is less than or equal to negative 6. If you graph this on a number line, it looks like it's going this way, and it looks like it's going this way, and then everything in the middle doesn't apply. So sometimes these absolute value equations can look kind of funky when you graph them. All right, any questions about this? All right, moving on. Okay, here's an extra. Oh, we have a question from Saroj. Hey, Saroj. Hey, Saroj, how are you?
Can you hear me?
I can hear you.
Yeah. Do we change the sign after multiplying both sides by negative sign?
Yeah, if you're dealing with inequalities, you sure do, or dividing by a negative as well.
Just you wrote that in absolute values when you're writing x, then you change the sign less than, but you did not change -6.
Yes, I did. Yeah, so the first equation is x is greater than or equal to 6, or x is less than or equal to negative 6.
Still confused.
Okay, what are you confused about?
Second one, like if this sign changes, the greater or small sign, the 6 does not become positive, or it stays in negative.
Let's imagine that it's not an inequality. Okay, let's just imagine it's equal. Yeah. What are my two equations?
X is equal to 6.
That's number 1, and?
X is greater than 6.
No, we're just imagining just an equal, just -6, right? These are my two equations, right?
Yeah.
Now remember, in equation 1, do I change anything or change nothing?
Nothing.
Yeah, change nothing. So now let's imagine that we bring our inequality back. So I change nothing. So x is greater than or equal to 6. Cool?
Yep.
Okay. Over here, I have to change stuff. I have to make this guy negative, and I also have to flip. I have to do two changes. Make it negative and flip.
Yep.
So that's why we're getting the flip right there and -6, like that.
Okay, got it. Thank you so much.
Yep. Anurag, how are you?
Hi, Greg. How are you?
Pretty good.
Yeah, Greg. So the way I do these inequalities with absolute values is I just remove the modulus first. Then I write
You
plus
mean
or minus x.
the jail bars?
Yeah.
The technical
Plus
term is jail bars.
Yeah. So yeah, plus or minus x greater than or equal to x. Then I flip the sign. So will that be an issue?
I mean, do you end up with these two equations at the end?
Yes.
Then I don't care.
Because
I mean, as long as you end up with those two equations, you can do whatever you're comfortable with, in my opinion.
Yeah, -x is greater than or equal to x, and once you multiply with -1 on both sides, you flip it.
Mm-hmm. I typically don't do it that way. I typically look after the inequality or after the equal sign. That's kind of the way that I like to do it. But if you end up with these two equations, no problem.
Yeah, probably. I think they taught me that way. I'm not sure.
Yeah. As long as you end up with the two equations, I'm cool. All right, let's go to Manoush. Hey, Manoush.
Hello, Greg. How are you?
Pretty good.
Well, I'm wondering that what if there was a negative sign behind the jail bars? Should we multiply the whole inequality with a negative first?
Do you mean like outside the jail bars?
Yes.
Yeah, so that obviously is going to change some stuff, right? We actually have a couple of exercise problems that will bring that into play. You can take a look at it.
Thank you.
Yep. All right, guys. Pratik. Hey, Pratik, how are you? Pratik.
Hello.
Hey.
Hey, Greg. Just before this question, you did x. -3 is greater than or equal to -6. Could you
Yeah,
explain that?
I was showing a case that doesn't work.
Okay.
Yeah. I was trying to show a case that doesn't apply.
Okay, I thought it was a important point.
No. Yeah, I was saying, like, for example, if you plug in a -3 here, does it work?
-3x is no.
No, yeah. So
No.
I was trying to show a case that doesn't work. Does that make sense?
Yeah. Okay.
Cool.
Thank you.
All right, Abrahami. Hey, Abrahami.
Can you hear me?
Yep, I can hear you.
Okay, can you go through this once again? I'm
Sure.
sorry, my internet connection wasn't stable, so I
So
couldn't
whenever, this is kind of the way that I think about absolute value. I always think about there's two equations here, not one, but two. And the first equation, you want to change nothing. Change nothing at all. Okay? See how I changed nothing?
join. Yes.
Okay. And then the second equation is make the thing after the equal sign negative. So this is now a -6. And because it's an inequality, we have to flip it like that.
Okay, got it.
Cool?
Yes. Thank you so much.
All right. Here we go. Exercise time. All right, you guys go ahead and try this one. I'll give you guys 1 minute. Good luck. Okay, do I want this 2 to be here? Do I want the 2 hanging out with the absolute value? No. So what we want to do is divide everything by 2 first of all. And then we get x plus 4 equals 11. And then now I have 2 equations, right? So equation number 1, change nothing. So x plus 4 equals 11. And then equation number 2, make the thing after the negative, or after the equal sign negative. So x plus 4 equals -11. So what do we get? We get -4. So x is going to equal 7. And then we do -4. X is going to equal -15. Now, for me, I'm big into redundancy. So am I just going to rest on my laurels and say this is true, or am I going to check it? No, I'm going to check it. Because even in simple math like this, maybe I made a mistake, right? It happens all the time. So if I plug in a 7 here, it's going to be, okay, so 7, 11, okay, 2 times 11, okay, that works out. If I plug in a -15, I get -11, but that turns into 11. Okay, everything works out. Cool. Any questions about this one? We actually had a problem of the day maybe a couple of days ago where we had to do some absolute value equations and one of the found answers didn't work. So it's always a good habit to plug stuff back in. All right. Balakraman, how are you?
Hey Greg, how are you?
Pretty good.
Yeah. Remember these things like extraneous roots when we deal with some equations. So could you say x is equal to -15 is an extraneous value?
What do you mean by extraneous value?
Like so certain values don't belong to the equation, even though they give you values like.
I'm not familiar with that term, kind of extraneous roots. I know that sometimes you can find a value and it doesn't work inside the equation.
Yeah.
But here it works, right? If I actually plug in the -15, do I get it to equal 22?
Yeah, it does.
Mm-hmm. So I don't think I would consider that, yeah.
Okay.
Mm-hmm. Okay. Any more? Yep, sorry. Any more questions? Hey, Sydney.
Morning, Greg. Piggybacking on the previous question, is the GRE going to do that?
To throw in extraneous roots?
Yes.
My guess is no.
Okay.
But the GMAT might.
Okay.
Yeah. Are you interested in the GMAT?
No.
Okay. What about if you're bored one day? Do you ever just do GMAT problems?
Actually, maybe.
Yeah. Trust me, you'll start to get into it because we'll be doing some GMAT problems. You'll see if you like them.
Okay. Sounds good. Thank you.
Mm-hmm. Dabo said I had maybe an extraneous root on my GRE. I'm not saying you're wrong, Dabo. I'm saying I tend to not trust people's recollection when it comes to the GRE. Like I had one person tell me, Greg, my GRE went verbal, quant. And I'm like, are you sure? Are you sure about that? Right? And they were kind of swearing up and down. And I'm like, that seems weird. That seems weird, right? So human memory is fallible. It's not great, which is why eyewitness testimony can so often be manipulated. Okay. Moving on. Go ahead and try this one, guys. I'll give you a minute. All right, here we go. So we want the absolute value chilling by itself. So we're going to plus 16 to both sides. And then we get jail bar 3x plus 4. Jail bar equals 1, 2, 4. And now we have our two equations. 3x plus 4 equals 1, 2, 4. Change nothing, which means 3x equals 120, which means x equals 40. That's equation number 1. Equation number 2 is the following. Negative 1, 2, 4. Minus the 4, we get 3x equals negative 1, 2, 8. So x is a negative 1, 2, 8 over 3. Of course, we can plug these in, see if they work. So that's going to be 120 plus 4. So that's going to be 124. Okay, that one checks out. What is that? So that is going to be a negative 128 plus 4, negative 124. Jail bars make it into a positive. 1, 2, 4. Okay, it checks out. Cool. Any questions about this one? Manasi, I'll answer that question very soon. All right, let's go ahead and do one more, guys. One more exercise. All right, so for this one, I'll give you guys 2 minutes. Good luck. I see some of you guys saying x equals 8. What? If I plug in an 8, that would be 64 plus 8 minus 4 equals 4? Huh? Okay, here we go, everybody. So how many equations do we have? 2 equations, right? So we have x squared plus x minus 4 equals 4. So that's equation number 1. This is equation number 2. X squared plus x minus 4 equals negative 4. This one's a little bit easier. Let's do it first. So x squared plus x plus 4 to both sides equals 0. So x plus 1 equals 0. So x equals 0 or negative 1. Okay, any questions about this one? Okay, we good? Okay. This one here, this is a quadratic equation. I mean, so is this one, but it's easy. This is a quadratic equation that's not that easy. So we do minus 4 to both sides. We get x squared plus x minus 8 equals 0. Now, is this factorable, yes or no? No, this is not factorable. So what I have to do is use what's called the quadratic equation. Are you guys familiar with the quadratic equation? Negative b plus or minus b squared minus 4ac over 2a. So negative b would be negative 1 plus or minus. B squared would be 1 because, of course, 1 squared. Oh, this, by the way, is a, b, c right here. Okay, so that would be 1 minus 4ac. Well, the good news here is this is actually going to turn into a positive, right? So what is that going to be? 4 times 8 is going to be, there we go, 32. So we positive that. And then finally, over 2. So the correct answer is negative 1 plus or minus root 33 over 2. And then those 2 right there. Okay. Any questions about this one? You guys are saying this is an unreal number. Is that accurate? Is this an unreal number? No, these are real numbers, everybody. These are real numbers. They're not unreal numbers. Hey, Pratik, question?
Hey, Greg, is it necessary to find out the x value? Because if you can see, x squared plus x is equals to 8. If you put that 8 into the equation, you get 4. Positive 4. And if you put
it's the same thing here. It's the same thing here, right?
Yeah, exactly.
Yeah, it's the same thing. You just took a little shortcut. Yeah.
But is it necessary to find out the value of x? I'm asking.
I mean, that was the exercise, right?
Oh, okay. So I used a shortcut.
No, you didn't use it. I mean, I like the shortcut. You just basically said x squared plus x equals 8, right?
Yes.
Yeah, I like that, but you still have to find the x value, right? And to find the x value, you have to use quadratic equation, right?
Okay.
Right.
Yeah.
So, like, for example, if I asked you how to find the x here, how would you solve it?
Would have taken the 8 on the other side.
Right. So x squared plus x minus 8 equals 0, right?
Yeah, exactly.
And then use quadratic equation?
Yeah.
Mm-hmm. Yeah, I feel like this is kind of the only route you have, right? But I like that little shortcut you did. That was pretty cool. Hey, Jenna, how are you?
Good, how are you?
Pretty good.
So I got the 0 and negative 1 right, but why couldn't you have done the same method for the other one?
Technically, I did do the same method for the other one. So this is a quadratic equation right here. Agree? Mm-hmm. This is also a quadratic equation. It's just one of these quadratic equations is easy to factor and the other one isn't.
But wouldn't it be easier to factor if you did it the same way as the other one?
Well, I mean, they're two different equations. So, you know, this one is factorable. Right. This one is factorable. This one's not. So whenever it's not factorable, you have to use quadratic equation.
If I were to come up to this question, would it just be safe to just do the quadratic equation then?
No, probably if this was an ETS question, they wouldn't ask you what x value is. They would ask you how many solutions. So they wouldn't actually ask you to solve it. They would say, hey, how many solutions does this have? And what would the answer be?
4.
4. Yeah. So you don't actually have to do the quadratic equation. You can kind of just do that, basically.
Okay, makes sense. Thank you.
Yep. All right, let's go to Asha. Hey, Asha, how are you?
Hey, Greg, based on what you said, if there's 4 solutions, I really don't need to calculate this because it's an absolute value. It's like, you know what I mean?
Yeah, but the problem is quadratics don't always give you a good solution. So that's the other wrinkle in the
Okay.
Yeah. But in this case, you do have 4 solutions. So you can kind of take a risk and just go, okay, there's 2 equations here. There's 2 different quadratics. Each quadratic has 2 solutions. Yeah, if you want to just go for that.
Okay, thanks.
Okay. Now, if you guys are interested in knowing how many solutions a quadratic has, there's actually a shortcut. You just have to look at the b squared minus 4ac part. Right? This is what's called the discriminant. It's called the discriminant. And whatever, the way this behaves determines whether you have 2 solutions, whether you have 1 solution, or whether you have no solutions. Right? So, for example, in our case, the discriminant was a positive or a negative number. Do you guys remember? The discriminant was positive. It was a 33. That gave us 2 solutions. If this ended up being negative, if this ended up being a negative bad boy, you're kind of running into that no solutions, right? Where you have no solutions to this. So these are just little shortcuts that you can do, little shortcuts. Now, do you need to know quadratic equation for the GRE? The quadratic equation is in the ETS Math Review Guide, I believe. Can you guys confirm that? Is it in the ETS Math Review Guide? I believe it is in there. So maybe. Yeah, maybe. Right? Anurag has a question. Hey, Anurag, how are you?
Yeah, hi Greg, I'm good. How are you?
Good.
Yeah, so when the GRE asks us the number of roots, will they specify real roots?
The
Number of real
GRE
roots?
never touches unreal roots.
Yeah, because if had they asked just the number of roots for this and we proceed with 4 because there is a modulus, we could, while solving, we might encounter imaginary roots also, right?
Yeah, it's possible. Like if you put this equation into Wolfram Alpha, it actually has like 6 roots. So it has like 4 real roots and 2 imaginary ones. But GRE would never touch that.
Okay.
Yeah, they would never touch that. But when you guys talk about absolute value, you keep saying the word modulus. Is that kind of an Indian thing?
Yes, Greg.
I've never heard that before. Yeah.
I thought that was a mathematical term. I'm not sure.
I mean, maybe it is. It's just when I was learning absolute value, I
yeah.
just never heard that term. Interesting.
Okay.
Okay. All right. All right. So Manasi, I believe, said, how common are absolute value equations on the GRE? The answer is very rare. Very rare. They're not common at all. In fact, I went through the entire Math Review Guide book, and this was the only one I found. Now, I also know that there's an absolute value question on the PP plus 3. So it does turn up. It definitely does turn up. All right, guys, go ahead and give this one a shot. This one here, you don't even really have to do an equation. My advice here would be just choose numbers. Okay, I'll give you guys 1 minute. All right. I think here you should use what I call my equal, not equal strategy. Is it possible to choose an m value that makes these equal? What if I were to choose m equals 0? So in that case, they're equal, right? What if I were to say that m equals 1? Well, that would be 26. That would be 24. They are not equal. So the correct answer is D. So that's called the equal, not equal strategy. The equal, not equal strategy, one of my favorites. You just kind of equalize them, then you don't equalize them, and then boom. So this was the only absolute value question I found. It's the only one I found in the math review book. I didn't look at the official guide. Okay? So what does that mean? It means we have to do some GMAT. Here you go. Question number 1, guys. I'll give you 90 seconds. Good luck. All right, we're going to do this one pretty slowly. So this has 2 equations, right? So equation number 1 is x is less than or equal to 3, or x is greater than or equal to negative 3. Does that work? Does that look like what I'm looking at here? Looks like no, right? Because I have the 5 here and the 3 here, so that doesn't work. So this one is going to be x is less than or equal to 5. Remember, change nothing. X is greater than or equal to negative 5. So the negative 5, it looks like it works, but the 5 doesn't work, right? I'm missing the 5, so cross that out. So this is going to be x minus 2 is less than or equal to 3. What does that translate to? That translates to x is less than or equal to 5. Does that work? No, I don't have the 5, right? See how I'm missing the 5? Okay, this one is going to be x minus 1 is less than or equal to 4, plus 1 to both sides, x minus 1, or sorry, x is less than or equal to, plus 1 to both sides, 5. Again, that does not work. So the correct answer must be E. Now let's confirm it. Let's go ahead and confirm it. So x plus 1 is less than or equal to 4, which means that x is less than or equal to 3. Looks pretty good. Equation number 2, x plus 1 is greater than or equal to negative 4, which means minus 1, x is greater than or equal to negative 5. It checks out. Correct answer is E. Any questions? Dabo. Hey, Dabo.
Hey, hello.
Hey.
Hey, yeah, good morning, sir.
Morning.
Yeah, how are you?
Pretty good. How you doing?
I'm fine. What is the level of difficulty of this question?
Easy.
Okay, thank you.
Yeah. Do you want a harder one?
Yeah.
They're coming. They're coming.
Okay.
Mm-hmm. Hey, Sydney. How are you?
Good. I actually have a question about the previous one.
Sure.
we don't have to flip anything. Aren't we comparing them? So don't we have to put an inequality sign?
Well, flipping usually implies there's an equal sign or there's a greater than or equal sign or some kind of inequality. Do we have that information here?
No, I thought we were making our own inequality.
You could if you really wanted to. Like, let's say, for example, I'll show you what I mean. Let's say this equals 5. Okay, so you could say m plus 25 equals 5, and then m plus 25 equals negative 5. And so in this case, what would you get? You would get m equals negative 20, and then what would you get in this case? M equals, so what is that? Minus 30?
Mm-hmm.
All right, hold on, let me check my math here. So this would be 20, yeah, plus 20. Okay, makes sense?
Yes.
Hold on, let me see. Yeah, m is 20. No, negative 20 was right. Are they both negative? Interesting.
Yes.
Yeah, interesting. Okay. And then plug in those two negative values into the m, and if you get different answers, from whatever this equals, like if this doesn't equal 5, then you can choose D. But I don't think that's the wisest approach here. What I would do is just plug in 0, plug in 1.
Okay.
Yeah.
Why my question doesn't make sense. Okay.
If you wanted to create your own inequality or your own equal sign, no problem.
I was just thinking about it since we're comparing A and B, but now that I am thinking about it and more awake, my question doesn't make sense, so we're good.
No problem. It makes sense. You would just have to create your own, right?
Yeah.
Mm-hmm. Hey, Manoush, how are you?
I'm good. Can you hear me?
Yep, I can hear you.
Okay. Well, first, I'm just wondering that before we run out of time, are you also going to please tell us about the graphs of absolute values? Because every time that they add a number to the graph, to the jail bars, and then they ask to pick one of those graphs, it's going to be kind of confusing.
GRE doesn't really talk about graph, placement or displacement or graph. I think they're called graph transformations. Is that what you're asking about? So, for example, like y equals x squared, and then what happens when you say y equals x squared plus 7? This is
inside of a jail bar.
Yeah, but even inside the exponent as well, right? This is not something they usually ask. So we're not going to be talking about coordinate geometry in this class. I very rarely see graph transformations on the GRE. I don't think I've ever seen it, to be honest. I mean, maybe it's on there. Maybe I can find an example, but it's a super rare topic.
But there are some rules that when they say, let's say, like to multiply it by absolute value of x minus 1, and then they want us to pick the right graph.
Oh, there's definitely rules. The question is, are they GRE problems?
Okay.
Yeah, so we just have to kind of keep in mind, we don't want to overload people with too much stuff, right? All right, go ahead and try this one, guys. I'll give you 90 seconds. Good luck. Okay, let's go ahead and solve this one. So again, we have our two equations. So in the first one, change nothing. Y minus 1/2 is less than 11 halves plus 1/2 to both sides. So y is less than 12 halves, which means y is less than 6. Is anything greater than 6 here? Well, yeah, this is greater than 6, and this is greater than 6. So we cross out D and E, right? Equation number 2, y minus 1 half. Don't forget to flip the inequality, negative 11 halves. Plus 1 half to both sides. Y must be greater than negative 10 over 2. Y must be greater than negative 5. So greater than negative 5 means that it must be lower than that, negative 4 and negative 3. So negative 11 doesn't work. This is negative 5.5. That doesn't work. The only thing that works is this bad boy right there. Okay, any questions about this one? Any questions about this one? Now, can we back solve this? Can I plug in the answer choices? Sure, no problem. I don't care. Yeah, I don't care. All right, let's try another one, guys. Go ahead and give this one a shot. I'll give you guys 90 seconds, 2 minutes, something like that. Okay, if we're doing this problem, I think a lot of people would probably get overwhelmed on where to even start. So you can do a couple things. Number one, you can plug in the values. That's kind of the shortcut. Just plug in these values and see if everything agrees or disagrees. Or you can start with equation number 2, because of course this has the absolute value. So equation number 2 is actually 2 equations, right? So S is less than or equal to 5, or S is greater than or equal to negative 5, which we can write like this. 5 and then negative 5. And then what we want to do is we want to test the extremes, right? So plug in the 5 and the negative 5 into this equation and see what happens. All right, so let's start with the negative 5. So 3r is less than 4 times a negative 5 plus 5. So that means 3r is less than or equal to a negative 20 plus 5, which means 3r is less than or equal to negative 15. Divide both by 3. R is less than or equal to negative 5. Okay, any question about this one? All right, now plug in the 5, see what happens. Let me use a different color. So when we plug in the 5, we're going to get 3r. I'm going to do a little bit of shortcuts if you don't mind. So this is going to be 25. Does everyone understand how I got 25? Right? I'm just plugging in the 5, right? Which means that R has to be less than or equal to 25 over 3. Now, one thing you'll notice is that this value right here covers this value. They overlap. So what do I care about? Do I care about this one or this one? Which one do I care about? Right? I just care about this one. They overlap. The R is less than or equal to -5 is included in this one right here. So finally, which one of these cannot be the value of R? Can it be -20? It looks like it's okay. Can it be -5? Yeah, it looks like it's okay, right? Can it be 0? Is 0 less than 25 over 3? Yeah, it looks okay. Yep, 5 works as well. The only thing that doesn't work is E. Now we can plug this in, right? Let's go ahead and confirm it. Let's plug this in. So we plug it in, so that means 60 is going to be less than or equal to 4s plus 5, which means 55 is going to be less than or equal to 4s, which means that s is going to be greater than or equal to 55 over 4. Now, is this possible, according to equation number 2? No, not possible. So, correct answer is E. Okay, any questions about this one? Hey, Tori.
Hi, Greg. How are you?
Good.
What level question would you say this is?
Yeah, Mahard.
Okay, cool. Thank you.
Okay, did you get it?
Yeah,
Nice.
and that's why I was excited.
Mm-hmm. Yep. Any more questions? Fahad says, what is Mahard? Medium hard. Hey, Aaron, how are you?
Yeah, I'm doing fine, thanks. How are you doing?
Pretty good.
So I wanted to ask you, in GMAT, you find a lot of these questions?
I wouldn't
So
say a
in
lot,
here-
but I think they're more common, but yeah.
Right. So I was wondering what level should we practice? Because, we can go down the rabbit hole.
I would not go down the rabbit hole with absolute value. I think it'd be a waste of time. So basically, problems like this level, don't go harder than this. This is about the limit.
Okay.
Mm-hmm.
Which is like 600?
Yeah, 600 level, something like that. Yeah.
Okay, cool. Thank you.
Midhoosh, how are you? You have to turn on your microphone, Midhoosh.
Yeah, Greg, can you hear me?
I can.
Yeah, so I'm good. How are you?
Good.
Yeah, so my doubt is when you have s less than equal to 5, the modulus of s less than equal to 5, you did s less than equal to 5 and s greater than equal to minus 5, right?
Right.
And then when you substituted the s greater than equal to minus 5 back in the previous equation, the 3r less than equal to 4s plus 5, what happens to that sign over there? Should that get, since this is greater than equal to minus 5 and that is just remaining as less than equal to, should that get switched? Or
No, because none of the operations I did, here, good question. So like when I plug in the -5, is that what you're asking?
Yeah, the s greater than equal to -5.
Okay, so 3r is less than or equal to -20, right?
Yeah.
Is that what you're saying? Plus 5?
Yeah, I'm confused as to why this sign should not change. Like, I know it should not change, but I want like a mathematical explanation for why this less than equal to should not change, because I'm plugging a s greater than equal to -5.
Right. Well, if you want a mathematical explanation, you came to the wrong place. Mathematicians hate me. Right?
Okay.
That was a joke. All right.
Okay.
So the reason why is the sign flips when I do the operation to both sides. When I do the operation to both sides. So when I substitute in the -5, am I multiplying the whole thing by -5?
No, you're just
No, I'm just substituting in, right? And then what I'm doing is 3r is -15, right? Like this.
Yeah.
And then am I dividing by a positive or a negative?
You're dividing by positive.
Exactly. So does that change anything?
No, that doesn't change.
So the thing is, I never did a negative operation to both sides, which means that's why it doesn't flip.
Okay. So
Cool.
the s greater than equal to -5 doesn't matter. That sign doesn't matter. Right?
Well,
You're just
there's
taking the equal to
overlap.
part
There's
and-
overlap, so you can just discard one of the equations. Yeah.
All right. Okay. Got
Yeah.
it.
Cool.
Thank you.
All right, Balak Rahman, how are you?
Right. I just couldn't understand after you simplified -5. The part after you made -5 greater than s is greater than -5 and less than 5, less than or equal to 5. Can you explain the part after that, please?
Sorry, one more time.
Yeah. So can you explain the part where you find the limits for s and then you work out for the next equation?
Oh, you mean like what do I do after that?
Yeah.
Okay.
Yeah. What do you do after that?
So do you agree that it's going to be, what was it, 5 and, was it -5? I forgot what it was. Yeah, 5 and -5. Okay, you agree with
Yeah.
this?
Yeah.
Okay.
I do.
So plug these s values into this equation at the top, and that'll allow you to find r, right?
Yeah.
Okay, so we do 3r. Which one do you want to plug in first, -5 or 5?
I'm -5.
Okay, so that would be -20 plus 5, -15. Agree?
Yes. So r is less than or equal to -5.
Exactly. Yeah, -5. My mistake. Exactly. Okay, so far so good?
Yeah.
So now we plug in the 5, so we get 3r is less than or equal to 25, right?
Yeah.
So r is less than or equal to 25 over 3, which is about 8. Let's just call that 8.
Yeah. Yeah.
Now the cool thing is r is less than or equal to 8. Doesn't it include this, yes or no?
Yeah. It does. It does.
So who cares, right? Yeah. It's the same thing, right? So now we know that r must be less than 8. This is less than 8, less than 8, less than 8, less than 8, not less than 8, like that.
Okay. Okay. Yeah. Got it.
Cool.
Thanks.
Yep, no problem. All right, let's go ahead and try one more here, guys. Oh, Deepasha has a question. Hey, Deepasha.
Hey, I don't know if I'm confused or I'm confusing you. S should be greater than equal to -5, right?
Right, that's why right here.
Okay, do you mind to solve it for option A here? Means putting the value.
Put in -20 and see what happens. Okay, so let's do that. So we have -60 is less than or equal to 4s plus 5. So that means -65 is less than or equal to 4s, right?
Yes.
And then s approximately equals what? 16, -16, something like that?
Yeah.
Okay, -16, something like that. Does that work here? If I plug in like a -15 or a -16, is this equation confirmed or violated?
It should be S should be cannot be the value, right?
Okay, let me do it all the way from the beginning. Hold on. -60 to 4s plus 5 minus 5 -65. So 4s, divide both by 4. So s has to be greater than, okay. So s is greater than -65 over 4. Okay, does that include 0? So can s equal 0 in this equation?
Yeah.
Yeah, so I can make this equation work, right?
Oh, okay.
Makes sense. Like I could say s equals 2. I can make this equation work, right?
Anything which should be greater than equal to -16, right?
Well, yeah, I mean greater than a negative. So s could be 0, s could be 1, s could be 2, right? Yeah, so it works here. Remember, this is a cannot, which means 100% it never works, right? Here, let's go ahead and plug in the 20. I think if we plug in the 20, it'll kind of illustrate this concept. So if we plug in the 20, we get 60 and then 4s plus 5, right? Which
Yes.
means 55, like this, and then 4s, which means that the s must be greater. And let's just call this, I don't know, let's call this 14, okay?
Mhm.
Just for fun. Okay. Can s be greater than 14? Is that possible, or is that never possible?
Not possible.
It's never possible. So in the -20 case, we could say, oh yeah, s can equal 0, but the minimum we can say here is like s equals 14 or 15. It just doesn't work.
Yeah.
Makes
no,
sense?
I got the answer, but I don't know why I'm confused. Okay, leave it. I know.
These inequalities can be really confusing sometimes. I agree. You know, flip, don't flip, that kind of thing.
Yeah, I got it. Thank you.
Cool.
Cool.
All right, let's do one more. If y is an integer, then the least possible value of this bad boy is what? And then let me add on kind of a little addendum. What is the least possible value? Or what is y? What is y when this is at the least possible value? Okay? So not just an integer, just what is y at the least possible value? All right, guys, I'll give you a minute or two. All right, so first of all, if y has to be an integer, which is what they tell us, what is the smallest I can make this? I mean, if y equals 0, it's 23, not very small. If y equals 4, it's going to be 23 minus 20, which is 3. But if y equals 5, what do we get? So 23 minus 25, and that's going to be a negative 2, and that's going to be a 2. Can I make it smaller than that? Is it possible? No. If y is an integer, that's as small as I can make it. Now, the addendum to this question is, what is the smallest possible value this can be? Can this ever be negative? No, so the smallest possible it can be is 0. So what does y equal in order to make this 0? So that means that 23 equals 5y, which means that y equals 23 over 5. Okay, any questions about this one? Manoush, that's why I said it's an addendum. Manoush, I said this is an extra problem. Right? Hey, Sentia, how are you?
Hey, Greg, how are you?
Pretty good.
Greg, I have a confusion here. When
Sure.
we say minus 5y inside a mod, it can never be negative.
You mean the y value or the result?
The result.
Yeah, the result can never be negative, yeah.
But when we say mod of x is equal to 5, then x is either 5 or x is minus 5.
Correct.
But then how that is possible? Then also x should always be positive, right?
No, you can substitute in negative values. It's just that the result is always positive. So take, for example, this, right? X plus 7 equals whatever, y. Can I put a negative number here inside x?
Yes.
Sure, no problem, right? But the result, the thing that it spits out will always be positive. Like, can y be negative, yes or no?
Yes.
No, because y is the result, right?
By the result.
No,
Yeah,
but
yeah.
okay, yes, y could be negative in the sense that, they're kind of like canceling each other out, the negatives or whatever, if you want to think of it that way. But, the result, let's just put it this way, the result is always going to be positive, right?
Yes.
Okay, but I can substitute in a negative value, no problem. So same thing here. I mean, I could put, for y, couldn't I say y equals negative 100? Is that okay?
Yeah, of course. We could put in.
Yeah, no problem, but the result would be positive. Cool?
Thank you.
Hey, Saleha, how are you?
Hi, Greg. How are you? Can you hear me?
Yep.
So I didn't understand the solution for the addendum. Can you explain that one more time, please?
Well, yeah, so if you want to minimize the result of an absolute value, so let's just imagine this is x plus 7. And we're talking about the result, not the x value. We're talking about the result. Is it possible to make the result negative?
No.
No. So the only thing I can do is make it positive or 0. So what would x have to equal to minimize the result to 0?
So it would be -7.
Exactly. That's what I was asking you. So what would y have to be to minimize this result to the lowest possible value, to 0?
So it would need to equal
23, right?
23, yeah.
Yeah, 5y would have to equal 23, which means y equals 23 over 5.
Oh, got it. Okay. So yeah, the first part, the way you explained it kind of helped me look, because I was looking at that and I was kind of getting jumbled, but that makes a lot of sense conceptually.
Keep in mind the first equation or the first question, is it asking about y or the result?
It's asking about y.
You
Oh,
need to
sorry,
begin-
the result.
The result, right?
Yes, sorry.
My question was asking about y.
That makes sense.
See the difference? I was kind
Yeah.
of, we were asking about different things. Yeah.
Got it. Okay, thank you.
Cool. All right. Shall we look at one more, or we have one more question? Prakar. How are you?
Hi, Greg. How are you? I'm fine.
Good.
Yeah. So right now you explained how to do it, like taking y as 23 by 5, then it becomes 0 inside the mod, right?
Right.
So what I thought it was like solving like earlier, like I considered 0 on the both sides earlier only, like 23 minus 5y equals to 0 and negative parenthesis 23 minus 5y equals to 0. So would it be like a wrong approach or like right?
I don't understand your approach exactly, but put it this way. You can test it very easily. Use your approach, all right? Plug in the y value, and the result should be 0. If you can get it to equal 0, then the approach is valid, right?
Okay, yeah.
Cool.
Okay, fine, I got it. Okay.
All right. Should we do one more? All right, guys, last one, then we'll call it a day. For how many ordered pairs, x and y, that are solutions of the system above, are x and y both integers? I'll give you guys 2 minutes, 120 seconds, if I can spell seconds correctly. All right, good luck. We're going to call this the GRE GMAT challenge. You have to solve this problem while listening to Friday. That's a great song. Are you guys ready? So the first thing you want to do is handle the easier equation. The easier equation, of course, is going to be this guy right here. So y is less than or equal to 12. Y is greater than or equal to negative 12. We can write it as the following. 12 and negative 12. Now, how many numbers is this to go from negative 12 to 12? How many numbers are we talking about? A lot of you guys are saying 24. Is that accurate? So you're saying negative 1 to 1 is only 2 numbers? Is that only 2 numbers? Don't forget the 0. So how many numbers are we talking about here? 25. 25. Okay? Everyone follow? Now here's the thing. Here's the thing. If y is odd, will x be an integer? No. Like take for example, if y equals 3. So that means we have 2x plus 3 equals 12, which means 2x equals 9, which means x equals 4.5. So what in these 25 numbers, do I want the even numbers or the odd numbers? I want the even numbers, right? How many even numbers are there? I mean, you could even brute force it if you want to. Negative 12, negative 10, negative 8, negative 6, negative 4, negative 2, 0. Greg, 0 is not even. 2, 4, 6, 8, 10, and then 12. All right, let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Correct answer is D. Cool. All right. Was that fun? All right, everybody. I have another class starting relatively soon, so we should call it a day. It's long passages. If that sounds like something you're interested in, I'll see you guys in about 50 minutes. Okay, bye-bye.